Normally, hyperbolic invariant manifolds are specialized geometric surfaces that remain unchanged as a system evolves over time, defined by a strict balance where the expansion and contraction forces acting perpendicular to the surface completely dominate any movement occurring along it. These structures serve as the geometric skeletons of a system, acting as invisible boundaries or pathways that govern transport, whether mapping the dividing surfaces of chemical reactions or guiding spacecraft through deep space. In orbital mechanics, these manifolds manifest as unstable orbits around points of gravitational balance between celestial bodies, forming interplanetary superhighways that allow spacecraft to travel vast distances with minimal fuel. While forces from planetary rotation can twist these paths into complex, swirling loops, the inherent structural stability and persistence of these manifolds ensure they remain intact despite small disruptions or noise. By executing precise engine burns to adjust velocity, missions can hop across these invariant boundaries or match their specific structural energy to drop flawlessly onto stable, repeating geometric tracks for long-term station keeping.